Sunlight falling on Earth varies greatly based upon the season. The average energy falling on a meter of Earth is 897.6 joules every second with a clear sky. This is far more than enough needed to distill pure water from bad water, provided a few conditions are met. Number one, you have sunlight. That is, it is not nighttime. Number two is you have a clear plastic sheet. Number three, you have a source of tainted or otherwise undrinkable water. And number four, you have a container in which to collect the pure distilled water. That is the bare necessities, though later I will mention improvements. In many of the world's deserts and of course islands, one can find adequate sources of undrinkable water. In the desert, one can extract water from damp soil, such as from an alkali or otherwise poisonous spring, using a solar still. One can also extract water from plant material. On islands, of course, one can use seawater. The principle is very simple. A source of water is heated by the sun into vapor, which is then condensed on a plastic sheet. A container inside the condensing chamber sits waiting to collect the condensed vapor. The plastic sheet is convex from the point of view of the container, due to a stone that has been placed on top of the plastic sheet. In a typical winter day with sunlight, one may distill around 2 liters of pure water per square meter of plastic sheet, provided one has enough undrinkable water to charge the still, and provided one constantly maintains the still by cleaning it. In the summer, of course, pure water production can easily triple to 6 or 7 liters per square meter of clear plastic. In the most basic setup, one first digs a pit in the ground. The ground may be sand or dirt. The size of the pit should be smaller in diameter than your sheet of plastic, with around 9 or 10 inches of margin all the way around. That's about 20 centimeters. A container is then placed in the center of the pit. One may use just about anything, including one's hat, if one lines it with a piece of the plastic sheet that has been cut off of the plastic sheet around near the corner. The plastic sheet is then spread over the pit rather loosely so that the center of the sheet dips down in a nice concave shape. This is one of the reasons why the pit must be smaller than your plastic sheet. A small stone or pebble is used in the center of the plastic sheet above the container to make a cone shape out of the concave shape. This, of course, is convex from the point of view of the container. One then saturates the dirt or sand with undrinkable water. Every now and then, the saturate needs to be recharged with more undrinkable water. How frequently depends upon how quickly the bad water distills, and also how quickly the bad water seeps into the ground and away from the solar still heat. One then seals the solar still with dirt, making an airtight seal. Any leaks will mean loss of vapor. Even a small leak will reduce the production of pure water drastically. There are several improvements one may make to the basic still, if one has the material. If you have limited water and another sheet of plastic, you will want to line the bottom of your pit with that second sheet of plastic to prevent your undrinkable water, which I call the saturate, from being lost to the ground. The saturate will pool around your container, so you may need to place a clean rock inside the container to keep it from floating away. Now and then, after several days of use, this second sheet will have to be cleaned with fresh water now and then to keep production of pure water at its peak. If you have a large supply of bad water and you can therefore afford to lose that saturate into the ground, you will want to skip the bottom sheet of plastic. Perhaps make a second still with the second sheet of plastic. The next improvement is to add a drinking hose, if you have one, that will reach from the inside of the pure water container to the outside of the still. This means you need not disassemble the still to get at your drinking water. That hose should be plugged when one is not drinking through it to prevent the pure water from being contaminated. Every now and then, an edge of the still must be lifted up to add saturate. If one has a pipe long enough, one can use a pipe to fill the still without lifting the edge of the sheet of plastic. This pipe must be plugged when the still is in use. Without a plug, vapor loss will be drastically reducing the pure water production. Note that if you only have damp mud to work with, you must change out your mud as water condenses out of it. This can mean constantly opening your still to replace that mud. But it is much better doing that work than dying of thirst. The best addition to the basic still, and the one I used in the Mojave Desert, is to use black cotton cloth inside the still, which I then saturated with the undrinkable water. The black cloth absorbs heat rather quickly, and distillation is rapid. The still I made was 40 inches in diameter, which is about 1 meter. This produced enough water for all of my needs, including washing, in the summer. Now and then I removed the black cotton t-shirts and washed them in undrinkable water to remove the dirt and dead insects that had concentrated in the fibers. Some additional notes. It is all a matter of heat, not temperature. Even a cool day will allow you to distill pure water from bad water. You do not want to use water that has glycol products in it, such as from an automobile radiator. To pasteurize water, it need only be heated. It does not need to be boiled. A solar still is usually more than enough to kill most microorganisms in water. If you can get black sand or black lava gravel, you will want to line your pit bottom with that material. Black absorbs sunlight and therefore retains heat. You can distill water in your solar still at night if you can build a fire and heat water. If you do not have a container to heat water in, you can still heat stones. Either way, if you can raise the temperature of the saturate inside the still by pouring hot undrinkable water in, or by pouring in cold undrinkable water and then tossing in hot rocks, you can make that undrinkable water condense without sunlight. I should also probably not mention this, but a solar still can distill alcohol. This is usually illegal, so do not add 10 pounds of sugar to 5 gallons of water. Do not add a cup of brewer's yeast. Do not let it sit in a warm place for around 14 days at 78 degrees. And then, by God, do not distill it in the solar still. That would be immoral and illegal. A final note, now and then one can find emergency solar stills for sale. The ones that come with life rafts are good for about 40 days. Eventually, all will fall apart due to the nature of sunlight and plastic. I use an emergency blanket made out of mylar because it is very strong and it lasts pretty darn good in the sunlight. I always carry at least one with me, and I usually buy them in lots of 10.